use 2015 to minus the corresponding year for the lowest temperature, 56.94 Fahrenheit, which is 1950. Okay, and so part A, when you see something like this in Pearson, in MATLAB, just do this. Use the biggest temperature to minus the smallest temperature. That's the numerator. Denominator, use the corresponding year for the highest temperature to minus the corresponding year for the lowest temperature. And let's do the math. Do you guys have a calculator? I'm gonna use my handheld calculator, and you can do the same. So numerator 58.09 minus 56.94. The numerator gives me 1.15. The denominator 2015 minus 1950. That gives me 65 years. And then I'm using the numerator 1.15 to divide by 65. I got a decimal very long. Is around equal to 0.17, 0.017. 0.01769 23077. But you do not enter that decimal to the cell. Read the question very carefully. We need to, let's go back to the question. The rounding instruction. Round to the nearest hundredth as needed. Whatever inside the parentheses, when you work on the Pearson for this course, whatever inside the parentheses, those are important information. Please make sure you do not ignore whatever inside the parentheses, okay? And this tells us how do you round the result and then put it in the cell, okay? Round to the nearest hundredth. Where is the nearest hundredth? This is tenth, this is hundredth. So nearest hundredth means we are going to keep 2 decimal places to the right of the decimal point. And we look at the digit right behind the rounding place. The rounding place is 1, right? The digit behind is 7. Because 7 is bigger than or equal to 5, we are going to round it up. So this number, when we keep 2 decimal places, the number is going to be 0.02. Okay, so here we are going to enter 0.02 Fahrenheit per year. 0.02. Right? And that's part A. Again, part A is actually to find the slope of the straight line that could model the linear trend in a graph. Part B, let's read the part B. Write a mathematical, I have the part B here. Write a mathematical model that estimates the average global temperature T in degrees Fahrenheit X years after 1950. So part B, we are going to use 2 variables, T and X. We're going to be very clear about what does T represent and what does X represent. T represents the temperature in Fahrenheit. X represents the number of years after 1950. That means when the year is 1950, X equals 0. Okay? X here represents the number of years after 1950. So when the year is 1950, that's the initial year. X is 0. When the year is 1960, X is 10. Do you agree? When the year is 2015, X equals 65, and so on. You see the relation between the year and the X. So we need to set up an equation. The equation can describe the linear trend. It has to be linear, okay? We only learn linear. in this course. So are you guys familiar with the slope-intercept form of linear equation? Y equals mx plus b. Does this equation ring a bell? Y equals mx plus b. This is the slope-intercept form of a straight line. Linear equation in two variables, straight line. So this is a straight line, okay? Yeah. So we are going to set up a linear equation in a slope-intercept form to model the situation. And the slope, actually, we already found. Slope is 0.02. Okay? Slope is 0.02. And the B here is the initial temperature, initial T. In other words, B here is the temperature, the value of T when in the initial year in 1950. So it's gonna be 56.94. All right. Once you understand, if you remember straight line pretty well, and this will be a very doable problem. It's been a while, but yeah. So it's a straight line. So we are going to enter this equation. All right, we're gonna enter this equation for part B. Again, m here is the slope. We found the slope from part A, 0.02. So m is 0.02. B, remember, is y-intercept. Y-intercept is the y value when x equals 0. So when x equals 0, that's year 1950. In year 1950, the temperature is 56.94. So the initial temperature is 56.94. Let's enter that here. A mathematical model that estimates. So as you can see, it's not exactly linear straight line. So this is just the estimation. In degree Fahrenheit, x equals after 1950 is. Be aware, you already have T equals outside the box. So you do not, listen, you do not enter this again, okay? You do not enter that again. You already have T equals, the Y value equals, the function equals. So we're gonna enter 0.02 x plus the initial temperature 56.94. 56.94. See that? So part B is just to figure out the linear equation, the equation of the straight line that can model the linear trend from the picture. Part C, the model, I have a part C here. If the trend shown by the data continues, use your model or linear model from part B to predict the average global temperature in 2040. Okay, so let's see part C. As the problem instructs, for part C, we need to use the result from part B. The part B, we have T equals 0.02x plus 56.94. One of the important significance of a linear model or any mathematical model is to predict the future value of the function. So we are going to predict which year, 2040. The year is 2040. Yeah, we can come here. Remember, we have those when the year is 1950, x equals 0. When the year is 1960, x is 10. When the year is 2015, 15, x is 65. Anybody can help me to figure out when the year is 2040, what's the value of x? let me repeat my question. Earlier we analyzed when the year is 1950, X is 0. That's the initial year. We see that as the very beginning. When the year is 1960, then X equals 10, right? Because that's 10 years after 1950. When the year is 2015, X value is 65. That's 65 years after 1950. My question was, what's the value of X when the year is 2040? 2040. 90. Awesome. Thank you, Mary Ann. That's correct. 90. Yeah, that's 90 years after, oops. That's 90 years after 1950. 1950. So all we need to do, since the part C is to predict the temperature, to predict the value of T, all we need to do is to plug in X equals 90. Okay, let's plug in. T equals 0.02 times 90 and then plus 56.94. I'm going to use my calculator. You can do the same thing. In this case, I'm not going to show you. I don't have a camera to show my calculator. I'll just verbal here. 0.02 times 90 gives us 1.8. 1.8 plus 56.94 gives us 58.74. That's the temperature, the predicted temperature in 2040, no, 2024, I'm sorry. This year is 2024, but it's 2040 in the future. So we're going to enter 58.74. Let's see, again, whenever you see something in the parentheses, please do not ignore. Round to the nearest hundreds. That means you're going to keep 2 decimal places. Use the answer from part B to find the answer. Yeah, we did. We used the equation that we had. What's my value? 58.74. 58.74. Hold on. Did I... What? Isn't here 2040? Oh, I understand. Because that was the question I copy paste earlier before the class, we start the class, and then I logged out, and then now I log in again, so the question changed. The question structure stays, but the numbers changed. Part C here is to predict the temperature for 2025. My bad. So let's do it again, okay? This time we are going to plug in the year 2025. Then help me out. When the year is 2025, what's the value of X? What's the value of X? Do you agree? Yeah, do you agree? 75, right? Let's see. Perfect. Yeah, correct. So now we are going to plug in X equals 75 instead. Yeah, we're going to change this to 2025. I copy pasted this question earlier, but I logged out. When I log in again, the question, the system giving me a different number. That's why we entered the wrong number. So we do 2025. For the year 2025, X equals 75. So we're going to plug in X equals 75. We multiply 75 by 0.02. We have 1.5. And we add 1.5 to 56.94. We got a 58.44. Do you have the same thing? There we go. You see that, guys? In previous semesters, this question is the challenging question for this section. I hope the explanation for the 3 steps could help you. And this is actually a very good problem about the linear modeling. So the trend is a linear increasing pattern. The first part, when we try to find a yearly increase, estimated yearly increase for the temperature, that's actually to find the slope of the straight line that could estimate the linear trend. And use the biggest temperature to minus the smallest temperature as the numerator, and you use the corresponding year for the highest temperature to minus the corresponding year for the lowest temperature. Use the denominator, put in the denominator, and then you'll find the slope. Make sure you round it properly. And the part B is to find the slope-intercept form of the straight line. Part A already gave you the slope. All you need to do is to find the initial year. So the initial year here is 1950. Just to put a number here. And then part C is to use the model to predict the temperature in the future years. Important thing is to figure out for a certain year the value of x, and then you plug in value of x to find the predicted value for the temperature in the future years. And let me know, is that clear? 2025 to 1950. Can you explain how you found the 75? Just to make sure I'm understanding correctly. Angel. Oh, okay. Walt explained. Thank you, Walt. Appreciate that. Okay, any question, guys? Let's try one more similar problem. So after we round, it's clear but somewhat exhausting to the nearest hundredth. To the nearest hundredth, let me explain. Let me give you a decimal.
Sorry, I was trying to type, but I was trying to say after we round to the nearest hundredth.
Yeah.
That's
so this is a tenth. Okay, this is a hundredth. It's hard for me to pronounce those stuff. Thousand. So rounded to the nearest hundredth means you're gonna keep 2 decimal places. You're gonna only keep 2 decimal places. You need to look at the digit after behind the rounding place. And if the number is lower than 5, you round it down. If it's bigger or equal or bigger than 5, you round it up. In our case, we round it up. Yeah, I believe some of you might feel a little bit struggle when you work on this problem. That's why I showing you the process. On the right side of the decimal, it goes backwards. So 100th would be the second digit to the left of the decimal. I hope that makes sense. Second digit to the right, I meant, okay, yeah, I got you. Okay, awesome, very good. Thanks for going through the process. It will certainly help. Okay, so we have a similar problem. This is a linear increasing. I think there's a question is a linear decreasing. Yeah, this one is a linear decreasing. Do you want to try again, try a similar problem? Let's see. This one is a linear decreasing. We only do linear modeling.
Wait, hold on. Hold on. So whenever I just did the problem on 22, the one that you just worked out, whenever I went to put in B, it made me put the decimal first and not like the year. It made me put that first, like the 56 point whatever. It made me put that in first and then the decimal that we got on the first problem.
Yeah, same. It did that to me. I wasn't able to figure it out. ended up getting B wrong.
Yeah.
And it's not letting me put in a 58.44 for C. So
Which part?
I'm on
B.
A or B or C?
On 22, I'm on B, and then she's on C. Like, we're both having the same issue.
What's the issue?
So
It made me
basically,
put the problem in backwards.
Oh, you mean part B, you enter 56.94 plus 0.02x?
No, I put it in just like you just did, and it told me I was wrong. And then I had
the number. Listen, your number would be different from mine. Look at it carefully.
No. I know that, but when you said that the problem should have been t equals such and like 0.02x plus 50 whatever, it made me put it in backwards. So I have to put 56.98 plus 0.02x.
Really?
Yes.
But it let me to put a 0.02x first though.
I tried putting that in 3 times, and I like the way you put it in, and I got B wrong.
Same.
I'm pretty sure if I put it in backwards like what she's saying, it'll work, but it just wasn't taking it.
Use integers or decimals for any numbers in the expression. Use the answer from part A to find this answer. I don't see the difference. I would appreciate that if you can take a screenshot of your problem and then email it to me. I want to know what happened on your end. When I access to the question, it should be the same with when you access to the question. The system doesn't treat me differently. And obviously, I entered the 0.02x first. All right. Okay, can we go to number 20 and see we have 3 minutes. Just quickly figure out the process. This is a linear decreasing, okay? Americans' trust in government and the media has generally been on a downward trend since posters first asked the questions on these topics in the second half of the 20th century. Trust in government hit an all-time low of 14% in 2014, while trust in the media bottomed out at 32% in 2016. The bar graph shows the percentage of Americans trusting in the government and the media for 5 selected years. Use this information to answer part A to C. This question is similar, but because the y-axis is about percentage, some students get a little bit confused on that. Part A is to use the information in the graph to estimate the yearly loss in a percentage of people trusting in government. Okay, so let's see which is government. The blue,